Hey everybody, and welcome to the UK Azure User Group. We've got a great session tonight with a product group session coming live from Redmond. We've got Liam Cavanagh, who's been here before. He's an old timer with the User Group, and but it was actually 5 years ago when we last had Liam on in a pub in Middlesex Street near Liverpool Street. And it was a great session then, and he's going to give us a bit of a refresher. What's new in Azure Cognitive Search? I'm pretty looking forward to this session. Liam's obviously very influential, being the principal product manager for the Cognitive Search product, and obviously it means if you've got any questions about it or its role in the world, definitely get on the Q&A. I'll be monitoring them, and hopefully we can ask a few questions at the end. Just one last thing before I hand over to Liam. We've got another session coming up on Tuesday, April the 20th, so I guess in a couple of weeks' time. And we're going to be talking there about data modernization and moving SQL workloads to Azure. So another data session then. And hopefully that'll be a good one as well. Anyway, without any further ado, I'll hand you over to Liam. Liam, take it away.
Hey, Andy, thanks a lot. And yeah, I really miss being in person with you. That was just such an amazing time at that pub. It was far too long ago, but hopefully things will change and we'll be able to get back in person. So thanks for inviting me. Thanks for everyone for joining. As Andy mentioned, I am a program manager. I work in the engineering group for Azure Cognitive Search. And so really, I wanted to give you basically an update on some of the new things that we've done. I have one thing that I'm pretty excited to show you. Is called Semantic Search. So I'm going to go through that capability. But just to kind of get started, I do want to spend just a minute or two talking about what Cognitive Search is. So for those of you that are not aware, oh, and by the way, I don't plan to spend much time in PowerPoint. I will have like 1 or 2 slides, but I mostly want to do this as a demonstration. And as Andy mentioned, please ask questions in the chat, and let's have this more of as a conversation. But for those of you that are not aware, so Azure Cognitive Search, it's one of our platform as a service technologies. It sits in what we call the Azure Data and AI, because we actually are a data storage. You can put your data into our search service and then provide and create a very strong search experience over it. We also integrate a lot of AI capabilities. For those of you that are aware of Cognitive Search, Azure Cognitive Search, you're probably aware that where we started is we started applying AI to data that we're bringing into the search engine. Because if you're ingesting data from documents like PDF or Office documents, you just get this block of text. So if we can go through that content and apply AI to classify it or extract out interesting entities or metadata, that really expands on the knowledge and what things that you can do. I have a demo to kind of show you that concept. That's one part, but then also, which I'll show later on, is this new semantic search, which is leveraging AI to really understand and provide a really great search experience. So applying the search query side of it as well. So because we're a platform and because we are very much targeted at developers, it's very customizable. So there's all kinds of different user interfaces that you can create and then tie in our APIs behind it to then power that user interface. So that's important to note, just like all of our data services, it's not a solution. We don't have an out-of-the-box solution UI on top of it. You build on top of it to perform and create the UIs that you're looking for. The other big things that we've really been working hard on is the security and compliance. You might be familiar with things in Azure called virtual networks that allow you to really secure the environment. So Azure Cognitive Search can participate in that through private endpoints, firewalls. We do encryption. We actually do double encryption of the content. We allow you to secure the connections all through API keys. So because of this effort, we've also found that a lot of organizations that previously were hesitant to put data in the cloud are now looking to do that, primarily healthcare, finance, financial services, insurance. They've had very sensitive data, so being able to have that in there has been pretty important. And from the usability perspective, it has all of the core search capabilities you would expect. So when you search, it finds the right content. It has type head, faceting. That's that idea of categories on the left side. You know, you go to a retail store and you search for black shoes and you want to narrow it down based on manufacturer, price, or size. That's faceting and filtering. So all of those capabilities are there, including geospatial. So with that, why don't I show you a little bit more detail on what this actually looks like. So I'm going to switch to the portal, and this is an example of a search service that I've created. Now, you'll notice here that each search service has a URL associated with it, because you're going to, as a developer, you programmatically access it through the REST APIs or through the SDKs. There are also keys, so that whenever you make an API call, you can send in either an administrative key or a query key to make sure that you limit access to it. It has all the types of things such as scaling. So what I can do is, as a search service, if I'm finding that I need to be able to scale up to handle more users, you know, it definitely increases the price, but you can scale to whatever you might need to. The other idea is partitions. So as you need more content, need to be able to store more content into the search service, what you can do is you can actually add that as well. So all that scaling up and scaling down based on whatever usage you need is part of that service. So let me go back. And so the first thing that people will ask is, well, how do I get content into that search service? And so let me show you that, and along the way, I'll highlight a couple of the new things that we've done. First of all, there's two ways that you can get the data into the search service. You can either use our APIs to just push the content in, create some JSON and send it to it, or you can create one of our indexers, which is like a crawler. And what you can do is you can actually choose one of our existing data sources, and a couple of new things that we've added are ADLS Gen 2. That is a fairly new one on top of the blob storage. And brand new that we just announced a couple of weeks ago is SharePoint Online, because we do find that a lot of people have content in SharePoint systems that they want to build a really strong and customized search experience over. So being able to tie this in is one of the new things that we have. But let me just walk through, and I'm going to choose one of our samples here just so you can see. We have a couple of samples, including hotels, and let me just choose this. Another fairly new thing that we've done is through, remember I was talking about the AI, where as you're bringing content in, what you can do is you can actually apply AI to it. You can enrich your data. So for example, what we can do is we can look through the content and we can do things such as language translation. If it's you have multiple languages, we can automatically detect it and convert it to different languages. We can extract out entities like organizations, locations, key phrases, all these things that are built into it. Or if you have your own models, your own logic that you want to apply, you can plug this in as well. So I'm not going to choose this because I don't really need to for this one. But if we, oops, clicked on the wrong button, sorry. And then what you do is, as you're bringing in the data, it creates a schema. So for example, in my hotels, we have all the different hotels. Here we have a French version of the description, an English version. We have analyzers that deeply understand those languages. And you can even do, this is a fairly new thing as well, which is called complex types. So for example, a hotel might have multiple addresses associated with it. So you can actually, just as you would see in JSON, attach in very complex structures that can be full text searched, they can be faceted or filtered. And then all we do is we create this indexer, and we can say how often do we want it to run. Since this is a sample, I'm just going to run it just the one time, and we'll go out and do it. So this is nice because there's no code. You can just simply point it at one of the data sources that you want. If you have blob storage with PDFs, we will automatically extract out the text from those PDFs. If we want to, we can do OCR, and then you can start searching it. So let me show you how that looks. And so here is that index that I just ingested, and let's see if there's any data. If I click on this, you'll notice here how we have a REST API, the request URL. Now, if you took this and put it in something like Postman, as long as you pass in the API key, you can send in the same search query. So I'll send in the search, and let's put in something like, well, it's hotel, so let's see if there's something about a resort. And you'll notice here how it changed search equals resort. So we're going to do a full text search. And here, of course, it's bringing back results where it talks about resorts. Let me make it a little bit more interesting and highlight the description. You can see here how we can start adapting this. Hopefully you start seeing how you as a developer can take this and say, you know what, in my UI, what I want to do is take some of the snippets and show them, like you see here, how we put emphasis around the words, the snippets of text where it matches the results. I can then start saying, okay, well, let me add in the faceting. So I'm going to say, and facet equals the category field, because there's a category field down here. So I want to say, break it down by the types of categories. And in the search results, we have of the resorts, there are 12 that are under category resort and spa. There are 4 budget, etc. So hopefully you can imagine how on that left side, maybe you show the categories. And then when some user clicks on on one category, what you can then say is, well, let me then filter on the category equals, let's do budget. So of course, then it limits it. It's a strictly limits. It's like a where statement in SQL, where I can quickly narrow down onto what they clicked on. And you can have many, many different categories. There are so many other types of things that you can build into this, but this is the fundamental basis of how you start getting content into your search service so that you can then start querying it and start using it. So with that, let me just switch over, and I'm going to show you a bit more of an extensive demo of how we used all of this and how we applied AI so that you could then start getting more insights and more of an exploration over this. So what I'm showing you here, and feel free to try this if you want, it's covid19search.azurewebsites.net. And we created this a little over 6 months ago now, actually probably more like 8 months ago. And we created it because with the coronavirus, what we found was that there was a very large number of researchers that were just struggling with the vast amount of content, journals that were coming in. They needed to understand and research the most current information and find what they were looking for. And we wanted to try to see if we could help in here. One of the things that was done is there's an organization called Semantic Scholar that was absolutely amazing. And what they did is they aggregated all of the different research journals. And there was even some organizations like Elsevier that submitted some of their content as well into this. And they formatted it into a JSON format. And it had things like the title, the body, the journal names and things like that. And at the time, there was only around 40,000 journals that were relating to this, but you can see how quickly it's grown. As you can imagine, just a vast amount of content, over 300,000 research journals just on the coronavirus have been created. But that's where things started getting hard because the researchers couldn't really find what they're looking for very efficiently. So what we did is we wanted to try to see if we could help them in any way. And let me show you some of the areas that we were able to do this. And I'm going to show you one particular example. I'm going to just type in the word hemorrhagic, and I can never spell it. So then it's nice that we have the type head. And I'm going to choose it right here and search. So I just searched for the word hemorrhagic because hemorrhagic fever is something that is quite commonly discussed, as you can see here in the content. There's actually almost 16,000, a little under 16,000 documents that talk about it. But as you can imagine, even with that amount of content, how do you really find what you're looking for? And so what we wanted to do, and this is where the AI came in, where as we were bringing in the content, although we only had the title, the body, and the abstract, we want to say, okay, can we add more knowledge to it? So what we did in this case, we have a technology in cognitive services called Text Analytics for Health. And what we did in this case is, as part of that ingestion, remember I was showing you all those entities you could choose, we tied in text analytics. And when we said, whenever we see a document, if it break it down by categories like body structures, diagnoses, examinations, family names, genes, signs, symptoms, whatever. And then once I have this, whenever a document comes in, if it talks about fevers, tag it. And we add that as a field. So then what I can do is I can then facet over it and filter. And now what we've done is we've actually narrowed it down to that relevant set of items. The other thing that we did, I'm just going to remove this for now. And what we also did is we started to apply AI in a different way, where if you look here, you can hopefully you can see I spelled it H-E-M. But one of the things, and I didn't know this at the time, but in the UK, the way that they spell hemorrhagic is H-A-E-M. And you'll notice here through the AI, what we did is we actually went through the content and we understood that there is a semantic similarity between hemorrhagic and hemorrhagic spelled H-A-E-M. And if I add this, of course, I could have just automatically done it, but you'll notice here, all of a sudden we get significantly more results. And that's where AI can really be helpful, because if I'm not getting the recall, if I'm not getting all of the information that's really useful to me, then all of a sudden it limits what I can do. Sorry about that, I forgot to put my phone on mute. And so then I can get into what I'm looking for much more effectively. So what I can then do is say, okay, I found what I'm looking for, and now let me click on a document. And this is where things get pretty cool as well. Well, you see this blue part, it goes around pretty quickly, where when you have vast amounts of content, sometimes rather than forcing somebody to actually go through this huge body and find what they're looking for, sometimes it's helpful to do summarization. This one is through a partner of ours, but there's many different examples of how you can do this, where what you do is you take the search query that somebody's asking, and then you extract out the most relevant pieces of content that is found in that body, so that you can then actually allow people to really quickly see what they're looking for and get down into it. This is another really interesting application of AI, because it can take both the context of the search query, what they're looking for, and map it to the content to help users find things very, very quickly. The other things is, once we've actually found in the content that's interesting, I can then explore it. So for example, because I've extracted all of these different categories, all the knowledge, I can then visualize it in different ways. I can say, show me the signs and symptoms based on that content that were referred to hemorrhagic. And then it'll go through and say, oh, seems like fever is pretty common, so let me double click on that one and narrow that down. And then maybe I say, okay, well, now I want to say who actually is written about hemorrhagic fever, and who are the people and how do they relate. And so I can go into here and I can say, oh, well, this Alex person seems to be a pretty important person. So I can keep doing that. And then once I've done exploring the content, I can then narrow it down. And of course, we have hemorrhagic fever. Alex, I'm sure somewhere in here it mentions Alex. There it is right there. So we've kind of narrowed it down to that particular area that researcher was looking for. But we can do other things such as scoring. So for example, we found that if we were looking for a content, well, this isn't very recent, so let me just remove Alex, because it looks like he hasn't done any articles lately. We can see here that if we search for the content, we can start actually scoring it based on relevance and other factors. So that's another area where this really becomes very, very critical. So for those of you that might be interested in learning more, I have this GitHub repository that has all of the code behind this, all of the user UI components, how it was done to actually ingest all that content, how to set it up, etc. So because of time, I won't go through that in more detail, and I really want to focus on the new semantic search capability, but hopefully that will help with it, some of the aspects. Andy, I'm curious, are there any questions that have come up so far that you wanted to bring up, or should I just keep going?
I think people are really loving it at the moment, so just keep on going.
Great, great. So I'll do that. So now I want to switch into one of the brand new capabilities that we added, and this is called semantic search. And to do this, I thought that one of the most interesting ways is to maybe show you through some live examples of some of the challenges that search engines today have. And I'm going to pick on some grocery store. I'm going to pick on Tesco, and I'm going to pick on Morrison's. But this is really, it's not unique to these retailers or these grocery stores. It's applicable to virtually every type of system, not just in e-commerce, but even in people that are building their own line of business search applications in their organizations. So what I want to show is this is Tesco Real Food, and I was just playing around with it this morning, and I said, okay, let me try to see if I can find some interesting examples of where search gets hard. So I'm going to type in broccoli, and they did pretty well. It gave the type ahead, broccoli, pasta, and salad, and searched for that. And we can see here that there are 190 results. That actually combines both recipes as well as, I'm sure down here, some actual items, some grocery items that we can actually look at. But if I change this in even a slight way, like let me just remove the C, the broccoli, and you'll see how it goes from 190 down to 1 result. So that is an obvious example, because people are always misspelling words. The other thing that I was looking for here in the US, there is a thing called arugula salad, and I'm going to search for that. Now, before I do this, I'll tell you that in the UK it's called rocket salad. So if I search for that, you can see here there's lots of different rockets, but this lettuce here, we call it arugula. So if I change that in any way, once again, it says, I get 0 results because it didn't understand the intent. It didn't understand the semantics of what I was asking for. And there's so much awesome content in here. There are recipes all over the place. It would be so amazing if I could just come in here and I could say, how many calories are in cake, right? Like it's probably in that content somewhere, but I can't even ask any questions. Once again, I'm picking on Tesco, but this is not unique to them. I mean, I can go to Morrison's, and they have similar challenge where, let me just do the arugula salad. Right, there's nothing, but if I do rocket salad, there's lots. Well, a number of them. So you can see here the challenge that these retailers have. And if you actually understand the background of how search engines traditionally work, you can kind of get how and why it happens. And so I'm going to actually bring up a slide here so that you can actually see, a little bit more detail on how that actually works and why it is the way it is. So traditional search engines, and this is actually even true of Azure Cognitive Search before we added the semantics, it was all very linguistic. It all used text. And what we could do is we can do variations of those words. So if I was putting in this search query, fine dining places in Switzerland, what the search engine is really good at is finding different stems or lemmas. So for example, dining could be reduced down to dine, its lemma. Places could be brought down to place. There's no real lemma or stem for Switzerland, so that's kind of what we would use as well. So if you think back to what I was just showing you with the arugula salad, it didn't know that rocket salad was the same thing as arugula salad. That's not a different lemma or stem of arugula is not rocket. So it's never going to find that result. It also didn't really understand my intent. Because if I ask how many calories are in cake, all it's going to use is it's going to use those words like how and many and calories and cake. And it's sure it's going to give more weighting to words like calories and cake because they're more rare, but it's really going to limit it. It's not answering my question. So when we actually add semantics, then what we can do is we can actually use knowledge to actually adapt to this. So for example, if we're looking at fine dining, that might mean 5-star or 4-star. Dining might be restaurants. Switzerland is similar to Geneva and Zurich. So we can actually start bringing in semantics to help recall or bring back more relevant information. And you can even have many more. And the way that we're doing this is we've leveraged the Bing knowledge that is being created every day. Every day, Bing is constantly scouring the web, is crawling the internet, and it's gaining a lot of knowledge. It's not only looking at that knowledge of the content, but it's getting the knowledge of what people are searching for. What do they search for? What do they click on? What are the typical intents that people have? And then through a vast number of technology techniques, including neural networks, it built up this knowledge layer. And what that results in is what we call the Bing ranker that we can then use to help us provide more insights, more knowledge into what people are trying to actually find. And if I go through this a little more, some of the things where this can help is, an intent. If I take this example of delicious Swiss chess, we know through the Bing knowledge that people probably didn't mean Swiss chess. They probably meant Swiss cheese. And we can adapt to that and change it and get a really viable result. And technically, the way that this works is through a two-phase approach. What happens is when somebody sends in a search query, what we do is we take that in and just through our traditional way of using search, using those the linguistic approach, we find what are the most viable candidate documents. So we quickly narrow it down to a set of documents. And then in the second phase, we pass it to this Bing ranker. And we say, hey, Bing, based on the query that came in, tell me what you think are the most relevant results. And it'll actually re-rank it to actually give you a better set of results based on the linguistics, the intent, the question answer, all those different things so that you can then get a good result. And I'll show you this link later on, but if you want to read more, you want to give this a try, this is where you go to. But let me just show you a couple of examples of where this can be really helpful. So I'm going to go into here. This is a demo that we have, and I'm querying a search index. So in Azure Cognitive Search, we have a search index. It's called MS Marco, and it's just a machine reading comprehension index that just has millions of different pieces of text just from different places on the web. And you can ask really, you can do different types of search, you can query it in different ways. So let's try a couple of examples here. So let's try, I'm going to search for broccoli in the correct spelling way and search for this. And just to kind of give you an idea of what it looks like. So if I search for broccoli, what I can do is I get the traditional search, but I'm going to actually just, change it. And I'm going to misspell it here, broccoli. And there's actually a couple of results here, but that's probably because they actually misspelled in the content. So what I can do is I can, through the search query, I can tell it, I want you to handle spelling mistakes. And it automatically adapts that. It looks at that and says, oh, broccoli was probably what you meant. We can rank this so that we can actually boost up the things that we think are going to be most relevant based on what you just asked. And you can even start adding in answers. So let me give you a couple of other examples before I do that. So let's bring up the rocket salad and search for this. You can see here, well, it found some that had rocket and arugula, but it's not really obvious if it was because of that. So let me add in the highlightings. So you can actually see here that I searched for rocket salad, right? But it knew that that's actually very similar to arugula salad, so that we can actually even still get to it regardless whether I type in rocket or I do arugula. And in fact, why don't I just completely misspell it? So I'll do arugula just to make it even harder. So we fixed the spelling and we brought back the correct result. And I'm sure somewhere down here, it refers to rocket salad. I won't look to it right now. And I can even start doing question and answer. Like, for example, how many calories are in cake? And what we do is we actually start bringing that in, and we actually, because we have the answers, what we do is we'll go through the content, rank it, so we have the traditional documents, but we'll show you what that answer is. So that maybe at the top of your search result, maybe you actually allow people, if we detect it's a question, to actually present back the answer to you, so you could show that as well. So hopefully, now obviously I looked at this from more of a grocery recipe type perspective, but hopefully you can kind of see how this might apply to almost any case. You might have documents in your organization that you want to be able to search for and find the most relevant document. Maybe some of your users want to be able to get answers to questions that they have that are hidden somewhere in that. And this allows you to do this as long as we get that content into Cognitive Search. Andy, are there any questions on that before I show how the technology behind this?
Yeah, there are. A couple of questions have come in.
Great.
First one is semantics, this is from David. Is semantics, hi Liam, very friendly. Is semantic search on by default, or is it one of the specialized options you need to select, like a language translation?
Good question. So let me first go to this link. I'm just going to do cognitive search, semantic search, and we should probably add the link to this so that people can see it, get to it more easily. So this gives you more detail on it. But to your specific question, if you look here, it is a preview, and it's where we currently only have it in these regions. So for example, North Europe and West Europe are probably one of the ones that you would, as long as you have a search service in there, you can just use it. You just sign up for this. We actually approve them pretty quickly. So if you want to give it a try, that's how you do it today. But let me also answer that question by showing you how it works. So I'll go to a different one, and I'm going to go to the search service. Let me use the just to be different, I'm going to use the COVID search index that we were looking at earlier. And what we can do is, because it's part of a preview, as long as you choose this preview API, and as long as you've actually registered and we've approved you, then what you can do is you can start doing queries. Let me just, I'll show you what it looks like before semantic search. So I'm going to search for what are COVID-19 symptoms? I'm just going to do a search for there, and I'm going to tell it to just bring back the title and the abstract. So let me search for this, and you can see here it didn't really do great with traditional search. You know, it used the words like COVID-19, and it probably found symptoms somewhere in here, but it didn't really do well. So let me show you. Actually, let me just add the highlighting, just so you can see what so you can see what it gets. So it's like they hit highlighting, got COVID. Okay, that's okay. It didn't really get a great mechanism for like what are the symptoms. So, you know, traditional search using terms doesn't do great. So let me change this and add in this semantics. So I'm going to change this, and what we do is we say query type equals semantic. So this tells us that we're going to use the Bing semantic layer, and we're currently only available in English. We're deploying it to multiple languages very soon, but right now it's limited to English US. And so we search for this, and then all of a sudden we get much better results. right? We get the text. We can also, let me actually add the answers. So I'm going to say, I want you to extract out the most relevant answers from this and show me this. So then I search for this and it went through the content and we got an answer, right? That I can then show in the results. And it says the most, let me see how it did here. So we can see here, it highlighted fever and cough. It highlighted, I can't say that word, sore throat, dyspnea, so you can see here how it did pretty good. It found the answer, and then maybe even in the document search results that we have here, here is the most relevant section based on what you just asked. So hopefully, to answer your question, if you have a search service in one of these regions, the North Europe, West Europe, you can just register, and all you need to do to start using it is start adding in these parameters. It is free now. There will eventually be a cost associated with this because these are backed by pretty strong GPU units, but today it's completely free for you to try. Hopefully that answered that question, but please let me know if there's any more details there. Andy, were there any other questions on that?
Yeah, we're coming in thick and fast now.
Great.
So Phil has asked quite a specific low-level question. I think it said, do you consider different meanings for the same word spelling, such as using something to tell the difference between bank in Riverbank and financial bank, or flood, people versus river flood, like some things that I've seen in BERT, for example?
Yeah, absolutely.
Specific question.
Yeah, so let's actually try this. Let's try Riverbank. I don't know what's going to happen. Let's see what happens with this in the MS Marco. So I'm going to compare it. Savings bank. Okay, here's a good one. They call it River Saving Bank. That's actually interesting. So it's not a great example. Long story short, yes. The way that this works is it understands the intent and it looks at the words together. Like, for example, if I type hot dog, I don't want it to think that a hot dog is like a puppy or something like that. I want you to take into the context that hot dog is a food, and then so it'd be wieners. Oh, actually, got Oscar Mayer Wiener Mobile. So like it understands the intent based on those words. So yes, it does take that in, and it will adapt to it based on that fact.
That's pretty cool. And there's one more question then, which Jared is being cheeky. He's asking a bit of a side question, but I think it's a good question anyway. He says that he's built an Alexa app that makes use of the Microsoft Graph OneNote API. And it seems like there's no search API for OneNote. So he was thinking about using Cognitive Search to fill that gap. Is that something you're considering to build into the OneNote API, or some kind of ingestion, I guess, into Cognitive Search, so that he doesn't have to do it himself? In other words, how expansive is your sort of ingestion plans, or are your ingestion plans going forward for these additional data sources that are out there?
Yeah. So what you might have saw, I went through it pretty quickly, but during our ingestion, one of the newest things that we added was the SharePoint Online, and that was like from the Microsoft 365 environment. That is the most common one that we see. But we do also see that people want to build more of a custom experience over other assets in there. The one that we see a bit more often is Teams. There's a lot through Teams. There's a lot of content that's being created, and they wanted to be able to build more of a search experience over, say, specific groups, conversations, or content that's put into those. So that's one area that we see. OneNote, we don't hear as often, but the fact is that, yeah, so we do see that there's a pretty strong alignment between content that's being created in Microsoft 365, including OneNote, OneDrive as well, plugs in. We don't have any, for that, we don't have any dates yet for when to do that, but you can actually do that today. Like for example, through Logic Apps, Azure Logic Apps, you can connect into a lot of these sources and take that content and push it programmatically to Cognitive Search. And you can also, I mean, you can programmatically take that content and put it into Cognitive Search. It's not as simple or as easy as that indexer I showed before. And we do think that that's important, but there's no time that it can give you. At least I can say it's not going to be in the next 6 months.
Cool. And last question for now from someone called Liam, who might well be you. I don't know. I didn't see your hand.
That's right. Oops.
I've asked question. But he wants to know what languages are currently supported in the spell check, and referencing back to earlier where we had some interesting differences between US and UK spelling. How does it work with different dialects or base languages?
Yeah, so currently it is just English, and I believe it's just ENUS today. But the fact is that when we focus just on ENUS, there's still a lot of queries that come in, that might be the UK version of that search. So that is all knowledge that's gained. And also, as we're crawling websites through Bing's crawling, there's just some knowledge there. Like it talks about rocket salad and arugula, and it starts to learn that they're similar. So it adapts to that from that perspective. But we haven't yet enabled it for the other languages. There are, most of the main European languages. Spanish here in the US is going to be pretty important. We're not necessarily sure how effective it's going to be in some of the other, I won't call them, primary, but the ones that people don't use Bing quite as often, because certainly the more knowledge, the more people are using it, querying and clicking on it, the more knowledge we can gain. But as we go to different countries, it may not be as highly used, so we're not exactly sure yet how effective that would be. But we do expect over the next couple months, we'll be opening it up to a lot more languages. And I think you will find that it'll do really, really well in some of those challenging aspects, compounding, decompounding, the different diacritics, all of those things that get very, very challenging in non-English languages as well. So that will be coming in the next couple months. Good question, Liam. It's like I see, like I put it in. No, it wasn't me.
That's it. That's it for questions for now, Liam. If you want to,
cool.
I don't think about going back to slides or whatever you have planned to next.
Yeah, no, that pretty much covers the vast majority of things that I wanted to show. I will highlight that, there are a bunch of different other changes, like for example, the networking, so that you can configure all of your virtual networks through here, or IP firewall. So there are a bunch of other really interesting things from that point that you can do. But I think I'll leave that for there. Looks like we've gotten through pretty much all the content I wanted. So let's see if there's any questions. If not, we can close a little bit earlier.
Great. Well, there was just a couple of links that were put up on GitHub. Maybe perhaps you could share those with us. What the COVID-19 app, and you got a doc link up, I think, for semantic search. It'd be a little bit hard to see on the screen, but if you could send them across, I can put them in an email to the guys afterwards and distribute that from the team. There was a question earlier that it came up, but the person didn't ask it. They asked me. They said they were going to ask this, and then obviously chickened out. Which was someone who works with us at Elasticloud said, do semantic searches understand custom analyzers? Do they work effectively after the custom analyzer maybe broken something into different chunks because of, like, if I've got dashes and I want to break something up because of that? And then can I then use it effectively after I've done other things inside, like more typical old-fashioned, in quotes, parts of cognitive search? Can I then use semantic search on top of it for even more value?
Yep. Yeah, great question too. So for those of you that aren't aware, first of all, analyzers are these things that are in the search engine that take the search query, all the terms or tokens, if you will, that are being sent, and it kind of adapts to it. So like an analyzer might be able to find, reduce the word running down to run. It can also do really fancy things like phonetics, right? Like if I'm searching for Cavanagh, and my name Cavanagh, and it's spelled Cavanagh, but in the content it's spelled Kavaanaugh. That sounds phonetically similar. So there's a lot of really cool things that you can do in analyzers, including custom analyzers, that can adapt to what you're trying to achieve. So the question is really great because yes, you can actually use both because the semantic search does two layers. First, it does the traditional search that may be using that custom analyzer that you created, or will use a custom analyzer if you've defined it to get the candidates. So let's say that you were using phonetic custom analyzers, and we found Cavanagh with the K, and so we have those candidate items, which is a good set. It's really quickly because of this algorithm BM25 that we have. And then we pass that to the Bing ranker, and we say, okay, based on that, now adapt those changes to it to what you think are the most relevant results. Now, that part does not use the custom analyzer in any way. It doesn't use any scoring that you might do. This is purely based on what Bing and the knowledge it has thinks is most relevant to you. So to answer your question, yes, the custom analyzers will help to get those candidates, and then that gets passed into Bing.
That's great. And because I think at the moment there's a risk of you getting off a little bit easy, I thought I'd ask a question that you won't want to answer. But I'll phrase it in a nice way, I suppose. How do you think this is going to end up looking in terms of both performance and speed of query? Mm-hmm. And how do you think it's going to look as well in terms of price performance? And is it going to be in line with the same sort of pricing models and things that you've got already in cognitive search, or is it going to really radically change a lot of that?
Yeah, good questions, and I think those are important to think through as well, because number one, the performance is a factor, because I don't know if you actually saw this, but if I did the search for this one right here, it took a little. Oh, let me just change it a bit so it actually searches it. So if you can see here that the second result took extra milliseconds to come back. It still wasn't a ton of time to get the results back, but it did, because remember, there's the two layers. It still does the traditional search that might be in the hundreds of milliseconds, and then we'll do the re-ranking, which adds a little bit of extra time too. It's usually in the area of tens or low hundreds of milliseconds to do that second ranking to get it, but it does add to it, which is a factor. So if you are in these sites where you need to get absolute quick response time, it's probably not the most viable thing, because it does add that layer. But so many people that we talk to find that it's way more important to get relevant results, even if it means 1 or 2 or a couple hundred milliseconds more to get the results. The other thing, and this is something that I think is going to be a factor for some people, is like right here is the pricing. So the expected cost is $500 US per month, which I think is, correct me if I'm wrong, is anybody, Andy, but I think that's around £360 per month for 250,000 queries. So that is, not small. And like for example, if you look at a high-end retail store that does millions and millions of queries per day, you can imagine this is going to add up quite quickly. So this is the pricing, I think, right now, to be completely open, is I think this is going to be something that we'll need to adapt to, because there will be some companies like retail and other ones that just send so many search queries, and they'll need more of a pricing that's more relevant based on the load that they have. This, I think, is probably still very viable based on most line of business applications, most consumer sites, because sending in 250,000 queries is a lot, right? And then you can also maybe even only use it when you think you need to. Like, for example, if you know that somebody just pressed enter, like, and they did a blank query, like, don't send it for that. So the important note, I'm glad you asked this, Andy, because it's an important factor to think of, is like this cost and the impact that it has. But it is priced that way because the GPUs that power this are a little bit more expensive.
Okay, no, that's a great answer. Thank you very much. And I'm a little bit disappointed that you were so well prepared. It's even in the official documents there. I thought I got you with a zinger, but always well prepared.
Keep going, man. You'll get me, I'm sure, pretty quickly.
Right. Well, I think that's it for questions now. I guess
Awesome.
just leave it over to you if you want to wrap up and say call to action you'd like or anything like that. Liam, over to you.
Yeah, no, thanks, Andy, and thanks to everyone for joining today. Hope you learned a little bit about some of the new capabilities. I've shared a few links in the chat window with Andy, so hopefully Andy can add those to you. So please feel free to give it a try, play around, and I also, my Twitter handle is LiamCA, in case you ever want to reach out to me. I'd love to hear from you. So thanks a lot, and have a great night.
Thank you very much, Liam, and hope to see everyone in the audience again in about 2 weeks for the SQL migration talk. But that's it for tonight. Hopefully we'll see Liam again, and we'll have to wait for 5 more years. But thank you very, very much for coming back, and it has been a real pleasure. Thank you.
Thanks, everyone. Bye.